Today I am going to show you how to solve this 8x8 Calcudoku puzzle. It includes the modulo operator, which makes it look pretty difficult, but it's not too bad, so let's get started. First of all, we have a group of cages here with only one or two possible combinations, so let's get started there. Here we have 2, 3, 6 and 7. This cage has just 5, 6 and 7. Here we already have the 6 in the column, so it becomes 2 and 3. Here is 1 and 7, 6 and 8, and 1, 2 and 8. Now if we look up to row 2, we can see that 2, 3, 5, 6 and 7 are in these cells here, leaving just 1 and 4 for these two cells. Now, next thing we can look at is in this row here, we already have 1 and 4 in this cell, which just leaves 2 and 8 as the only remaining values for this cage. So let's put in 2 and 8. Now, we have a pair of values here with 6 and 8, so we can remove 8 from this cell. Now let's look at our first modulo cage. We're not going to get bogged down in doing lots of calculations. All we're going to just do is put in all the possible values, and makes it much easier. Now if we look back up at where we started, we can see that we have this cage that must have a 2, this cage that must have a 2, and we also have this cage that has a possible 2. So one thing we can take from that is that if this cage has a 2, then this cell becomes 2, and this cell becomes 2. And that will become useful shortly. Now if we go back down to this cage here, well, it looks like there's lots of combinations. There are actually two ways of looking at it. If it has a value 1, that will work with any other value. But if it doesn't have 1, there is only one combination that's left. So if it doesn't have 1, it would have 3, 5, 6, 7 and 8. So the only remaining possible combination is 3 and 6. So let's have a look at that. If it contains 1, then this cell here would be 2. But if it doesn't contain 1, and this cage would then equal 3 and 6, we can go back to the link we found a short time ago and see that if this would become 2 and 7, so this cell would become 2, and this cell would become 2. So that we can see with either of those two possible variants that E4 equals 2. So I'll just take it back to where we started, and we can put the value 2 in there. I just might explain that a bit more clearly. So if we put that back to 1 and 2, it's straightforward that if this cage has a 1, then E4 equals 2. But if this doesn't have 1, I'll just take that out. The only possible value left would be 3 and 6. If we remove 3 and 6 there, that becomes 2 and 7. H2 becomes 3, H3 becomes 2, and we can remove 2 from there, which leaves E4 2. So with whatever happens with the cage down here, E4 becomes 2. And we can now remove 2 from the other two cells in that cage. Now, we'll come out of these two cages here. Once again, we're not going to get bogged down with doing lots of combinations. And calculations, we're just going to put in every available value in these two cages. And now we can remove 1 because you can't have a 1 with 3 mod. And we can see here we have a pair with 1 and 8, so we can remove 1 and 8. We also have a pair here, which we found earlier, with 6 and 8, so we can remove 6 and 8. And also, this cage here must have 5 in there twice, so one of these must be 5, so we can remove 5. Now what we're going to do now is we're going to add all the cells within rows 2 and 3. So we'll add all those cages. We'll include everything in 13, and then these 2 cells plus these 2 cells. Now we know that in each row and column we have numbers 1 to 8, and that totals 36. Now if we add up what we have here, highlighted in the blue, it gives us a total of 72. So that means that cell A3 and B4 must be the same value. And we can see that the only 2 values that they both share are 3 and 7. So let's put those 2 values in there. Now if we look back to row 3, we can see that the only 2 cells that could be 4 are in this 13 plus cage. So that means we can now remove some values from these 2 cells, because the only way we can get 13 with that 4 and the 3 and 7 here is with 2 or 6. So we can just remove the 3 and the 7. Now just while we're in this area, we can just fill in every remaining value for these 2 cells. Once again, we're not going to do any complicated calculations. And again, down to cage A6, we're just going to put in every available value to save doing anything too complicated. Now if we look up to cage B1, we can see that it must contain the value 1, because if it didn't, we would just have 4, 5, 6 and 7, and you're not going to get to a result of 0 with those values. So we can remove 1 from that column. And in this cage, it must, for the same reasons, must have a value of 3, because 5 and 7 would not give a result of 3. So we can remove 3 from that column. Now if we look at this cage, that doesn't have too many small values apart from the 1. So if we look at what's possible there, it looks like there's a lot of combinations. But without the 1, if we were to take that out, the only one we would have left, we'll just take that out to demonstrate, is 8, 4 and 3. So we can see that's a problem, because if we have a 4 in one of these cells, this cell will become 4, and we have a 3 here, and that would throw up a problem for our 13 plus cage. We'll leave 6 and 7 here, so you've already got 13, so it's not going to work out. So we know that that combination doesn't work. So if we just go back to where we were, we know that this cage must contain 1 in one of those 2 cells within column A. So that means we can remove 1 from the other cells in the column. So that means we've now solved that for 4. We can remove that 1. We have never solved cell there. Just remove the 1. Now next, let's go down to these two cells here. We've got 0 minus with 4 cells. That could be a lot of different combinations. So once again, we're just going to put in every possible value that's remaining. And we will do the same thing for this cage here, once again avoiding any complicated calculations with the modulo operator. Now if we go back up here, we can see that in this cage we must have a 6, and in this cage we must also have a 6. And also this cage must have 2 5s, so we can remove 5 and 6 from the other cells within those two columns. Now going back to this cage here with the 0 minus, because it's got so many cells trying to get to 0, it must have a 1 in there somewhere. To make that clearer, I'll just remove it and it will make it easier to see. So without the 1, you would have to have either 7 or 8 here, and with only 2, 3 and 4 as the smallest values here, that's not going to work. So I'll just put the 1s back in. Now if we know that this cage must have a 1, and we've already established this 1 minus cage must have a 1, we can remove 1 from the other cells within those 2 rows. So remove that 1 and that 1. Now next, if we go back to cage E7, we can now see that with the 1 gone from E7, that 5 is no longer a possible value in E8, so we can remove 5. Now, might not look it, but from this point it is all just basic steps to finish the puzzle. That's the hard work done, so I'll just quickly go through what's needed to finish the puzzle. In cell D8, the only possible value left that's unused in that row is 5, which gives us 3 in the other cell. Now from this point I will automatically remove pencil marks for solved cells just to save a bit of time. Next we can solve cell A1, so A1 equals 5. And if we go down to row 4, we can see that C4 is the only cell with 5. And then H4 becomes 1. The next thing we can do is calculate the values for this cage, and remaining possible values are 1, 2, 4 and 6. Then we can see that C6 is the only cell in that column that can be 3. Now we can calculate this cage, which gives us the values of 4 and 7. Now if we go over to column H, we can see that the only 2 remaining values are 4 and 5. We already have a 4 here, so that becomes 4 and 5. Next we can see that the only 2 in row 6 is in F6. The only 4 in column G is in G5. And the only 4 in column B is in B3. Next we have B1 is the only 7 in row 1. We'll remove pencil marks and it will solve several other cells as we remove pencil marks. Next we can see in row 1 there's only 2 values left unused, which is 1 and 6. And we already have a 6 here, so we can put in 1 and 6. And now we can solve this cage by putting in 7 into E2. Now if we go down to G8, we can see that 3 is only one cell in column G, so we can put in 3 there. That leaves to several other cells being solved. Now we can see that in column A, the only place we could put 6 is in A5. Now we have some columns with only one cell left unused, so we can fill those in. B5 equals 5, D5 is 8, E5 is 3, and in row 5 we get F5 must be 1. Just remove those pencil marks. Now we can see that in G6 it is the only cell that can have 1 in that column. Remove those pencil marks. Now we can solve this cage with 5, 2 and 1 already in place. We know that F7 must be 8. Now remove pencil marks. That should take us through to the puzzle being finished. We just follow that through and that's your puzzle solved. Thanks for watching. If you have any questions, just put them in the comments and I'll do my best to get back to you. If you would like to see more puzzles like this, I have a link in the description to a website that's worth having a look at.